All right, let's go.
Hi everyone, my name's Michael and I'm a rising senior at Monte Vista High School and in Cupertino, California. And my project is also the phone controlled robotic arm, which I'll be demonstrating uh, right now. So as you see, I have a phone app with the sliders on it, and I can select a Bluetooth, uh, the ESP32 through Bluetooth, and I'll control I'll control the servo motors with the sliders right here. See, right now I'm moving the claw in and out, and I'll move the robot arm back forward and backward like that. And the waist like this, right and left, yeah. And I modified the project by adding an ultrasonic sensor up top that automatically closes when an object comes within range of it. I'll do that right here. Oh, it wasn't supposed to do that. Hold up. Yeah. And for this presentation, I'll be focusing on the ultrasonic sensor part of the project and how it works. Right now, I'll share my screen, and so right here is a diagram of a basic gist of how it works, and uh, I'll be comparing the ultrasonic sensor technology with bats and how they see in the dark. And as many of you likely know, bats are blind and yet can navigate themselves in the dark with great accuracy. And they do this with a technique called echolocation, where they make sounds that high-pitched sounds, and their ears detect them when the echo reaches back after it encounters an object. And that way they can see, quote unquote, see what is around them and how far everything is. Ultrasonic sensors use very similar methods to obtain the distance from objects. And they do this by emitting sound waves, as shown here, with the emitted waves are red in this diagram. And after hitting the object, they echo back as the blue dotted ones, the reflected wave. And the reflected wave creates an electric signal once it reaches the ultrasonic sensor, and the sensor determines the time between the waves release and the electric signal when it returns back. And using this time, it, it is able to calculate the distance between the sensor and the object using the formula distance equals speed times time. And since the speed of sound is already known in dry air at 20 degrees Celsius, it's 343 meters per second. Multiplying speed times time gives the total distance traveled by the sound wave, or the total distance that the emitted wave travels and then reflects back. To get the distance between the sensor and the object, this sensor will divide this value by 2 to just get this one-way distance right here. And one issue that arrived with the ultrasonic sensor was that it only determines distance between the object, not the size of the object. So when I was doing the automated closing of the claw when an object was coming in, uh, if the object was too big, the servo motor would keep trying to close, even though the object was blocking it. And if this was left unchecked, it might lead to problems for the servo motor. So in the future, a possible solution would be to implement maybe a pressure sensor to have the servo motor stop turning when the objects are held firmly in place, which can be detected by maybe how much pressure is being put on the claw. And in this project as a whole, the challenge that had the greatest impact on me was from the first week when I was still connecting my robotic arm to my computer with an Arduino. And after a few moments of running the program, the robotic arm would simply stop turning even when I would command it to. And I would debug it by printing to the serial monitor, and it stopped printing too. So I knew that the program was crashing. And I I started debugging that after that by uh, individually testing each of the servo motors to see if and there was anything wrong with one particular part of my code. And after determining that my code was okay, my instructor and I agreed that it was an issue of power, where my computer was not supplying enough power to the servo motors, and that was causing the program to crash because the computer didn't like it. And that's when I decided to uh, plug in a 9-volt battery into the Arduino, which solved the problem because now the servos were getting enough energy to run continuously without fault. And through Bluestamp, I came to really enjoy both the building and the software coding aspects of the project, and especially like assembling the ARM and creating the app on the MIT App Inventor. Those were the most enjoyable things for me. And uh, after thinking about it, after coming to Bluestamp, I'll look more into both mechanical and the computer science aspects in the future. Oh, yeah, I think that's about it. Thanks for listening.
Awesome job, Michael. That was great. I got one question for you. If you had all the time in the world, I think I already asked this, but what would you add on to the project? I know you had something in mind with that involves a claw.
Yeah, I think it would have to do with the the claw and the pressure sensor potentially, because right now I just have one object that it's closing a specific amount for. I want it to be able to work for a more variety amount of objects, more not just this one. And in order to do that, it would have to have a variable amount of turn, which I don't have right now.